To a session on number system, this being almost the last portion on it in it sorry herein we will be taking up exponents of real numbers. Let's first uh, make a brief discussion on the positive and the negative powers, the laws related to that. Suppose I'm writing some 5 to the power 3. This means, or this refers to 5 multiplied 3 times, that giving me 5 5 25 5 125. If I'm suppose writing 2 upon 3 whole cube, that means it is 2 upon 3 is multiplied 3 times. Becomes 27, sorry, the denominator is 27 and to the 4 to 8. If it is a negative power of the same number, that means we are multiplying negative 2 upon 3 3 times. So the answer becomes minus, that is negative, negative, positive, positive, negative is another negative, so it becomes minus 8 by 27. For so for any non-zero real number a, if I'm writing a to the power 0, that should give us a 1. So that means if I'm writing either 3 to the power 0, that is also 1. Even if I'm writing like 3 by 2, that to the power 0, that also should be 1. Now when there is a negative power, that means I'm writing a to the power minus n. It means it is 1 upon a to the power positive value. If I'm writing 2 to the power minus 3 in that note, it becomes 1 by 2 to the power 3, so that is 1 upon 2 into 2 into 2, that gives you 1 upon 8. If I have a fraction and that to a power of a negative power, in that case what happens? If it is 1 by 1 upon n, that makes it 1 by 3 upon 2 to the power 3, thereby reciprocating it. So it becomes 2 by 3 to the power 3, so it becomes 8 upon 27. Now what are the laws of these exponents? Let's take it up. The first one being a to the power m with a to the power n gives you a to the power m plus n. That means if the power of if the bases are equal and they have different powers, remaining the base, the powers get multiplied. This can also be proved, like if I have 2 to the power 3, I also have 2 to the power 5. Now to do so, what do? I'm doing 2 into 2 into 2, and then there are 2 more. So that that is, I'll not make it 5, it will be too long. Let me make it 2, so that is 5. So I'm multiplying 2 to the power 2, 4, 4 to 8, 8 to 16, 16 to is 32. Now this 32 can also be expressed as 2 to the power 5. Or I directly omit this and write there 2 to the power of 5. If you see, the powers have actually got added. So when you have bases are equal, the powers get added. This is the first rule. Second one, a to the power m divided by a to the power n. This can also be expressed as a to the power n divided by a to the power n. Here in both the cases, the powers get subtracted. So if the bases are equal, the symbol is a division, the powers get subtracted. Let's take up a few questions on these two rules. Okay, I'll just note down the third one as well at the same time. If we have a power a to the power n with another power here outside the bracket, which I'm naming as n, then this is equivalent to writing a to the power m into n, or it's also equivalent in writing a to the power n and bracket m. They all do mean the same. This means the powers are getting multiplied. I'm not taking up the first few examples in rational powers. I will be taking up the simple natural number powers. The first question I take up, suppose, is 5 to the power of 4 multiplied to 5 to the power of 3. The answer will be in exponent. I will be expressing it. Now this is the first rule being applied. The bases are equal, so we'll add the powers. It becomes 5 to the power 4 plus 3, that is 7. The other one being, suppose 5 to the power 7 divided by 5 to the power 2. So that would make, apply the second one, then it would make 7 minus 2. The powers get subtracted, so the answer becomes 5 to the power 5. I also take up one with the third law application. Supposedly 3 to the power 2 whole of 5. This is equal to, the power will get multiplied, thereby making it 3 to the power 10. This is a simple application of the three laws. Okay, I also need to tell or share herein two more kind of expressions. If I'm writing a b inside the bracket and externally there you have a power, that means it is a to the power n multiplied to b to the power n. Also the same thing with, if it is a by b to the power n, I made a mistake here by writing by n, this is also equivalent to a to the power n divided by b to the power n. Now let us take up a question which says, evaluate this. I'm writing 2 to the power 11 to the power 4 into 11 upon 3 whole square into 3 by 2 to the power 3. We simply have to solve this. Writing this is meaning I'm writing 2 to the power 4 by 11 to the power 4. I don't need this. Then I have 11 to the power 2 by 3 to the power 2, and the last one being 3 to the power 3 by 2 to the power of 3. So that makes this getting cancelled, will be left with a 11 to the power 2. This will be leaving me a 2 in the numerator, and here also 1 3 will be left. So in the numerator a 2 is left, a 3 is left, and in the denominator 2 11s are left. So the answer becomes 2 3 6 11 11 121. We can take up here another question. Two to the power of 55 multiplied to 2 to the power of 16 minus 2 to the power of 97 into 2 to the power of 18. In this case, the first part, this part becomes 2 to the power 55 plus 60, that makes it 115 minus 2 to the power again 97 and 18 would be 5, 10, 11. So it is 2 to the power 115 minus 2 to the power 115, that makes it 0, whatever be the value. Let me take up one more here, we can fit in. 2 to the power, 2 to the power, 2 by 3 to the power, is 2. 2 by 5 to the power minus 3 and 3 by 5 to the power of 2. In this case, we write it as 2 to the power 2 by, I said 2 and we're writing 2 here, 3 to the power 2 into, this is actually 1 by 2 upon 5, which will later on be a reciprocal, and this is also 3 to the power 2 with a 5 to the power 2. That makes this, I can write the whole thing again because I need to reciprocate the second term as 5 to the power 3 by 2 to the power 3 into 3 to the power 2 and 5 to the power 2. If we see, this whole thing gets cancelled, this whole thing gets cancelled, this whole thing gets cancelled. So in the numerator we are left with a 5 and a 3. In the denominator we are only left with a 2, and that makes it 15 upon 2. We now take up a different type of a question. It says A is given to be 2, B is given to be supposedly 3. We have to find like A to the power B plus B to the power of A. That means it is 2 to the power of 3 plus 3 to the power of 2. So we can need to simply simplify this. It is 8 plus 9, that will give us 17. Similarly, it's asking about A by B to the power A with the same values of A and B. So it is 2 by 3, and on the numerator as a power it becomes 2. So it is 2 by 3 into 2 by 3, that makes it 4 by 9. There is one more to go, and then next we would take up rational exponents. We have only been taking up numbers, natural numbers, or with the negative power. Well, next we'll be taking up rational exponents. Okay, let me just complete this one. It says it's A. So 1 by A, that's 1 by 2, plus 1 by B, that's 1 by 3, and this whole power A become 2. So let's solve the part which is inside the bracket. I'm getting a 6, so it is 3 plus 2, the bracket and the exponent will remain as they are. So it's 5 upon 6 to the power 2, and that makes it 25 upon 36. I hope these were not that difficult. Next, once we take up rational powers, then we will need to concentrate more and follow it better. Thank you.